welcome to Convict Lake. The streaky and folded rocks over there are metamorphic rocks of the Mount Morrison roof pendant. By roof pendant we mean that there's sort of plutonic rocks on either side. Right here they don't outcrop very well, and most of the rocks around the lake are actually metamorphic rocks. The metamorphic rocks here mostly are metamorphosed sediments from the upper Paleozoic. So, maybe like 300 million years old, something like that. And they've been metamorphosed and folded up quite a bit. Some of the folding actually comes from mountain building before the Sierra Nevada batholith and the plutons came, but the metamorphism in this area is basically contact metamorphism. So it's high temperature, relatively low pressure. These are basically what we'd call hornfels facies rocks. You can see some here in the lake. These are basically all pieces of these metamorphic rocks, and you can see that they're not the most attractive colored rocks. They tend to be kind of rusty. They're fine grained, so it's usually hard to see individual minerals in them. They're really not the most attractive type of metamorphic rocks, at least up close. They look really pretty in the mountain, but that's just a fact of it being this high temperature, low pressure. Basically, they're heated up to a high temperature, but only because it's in the shallow crust. They cool back down relatively quickly, and there isn't a lot of time for big crystals to grow, basically. Which is why they retain this fine-grained texture that makes them difficult to really identify the minerals clearly. Specifically in these rocks, a lot of those white rocks are calc-silicates, and specifically the really white layers up there are big bands of a mixture of calcite and wollastonite, basically. And wollastonite is a metamorphic mineral that grows only when there's a large amount of water that's been added. And so those white zones, if you look closely, they sort of actually follow some fractures you can see in the hillside there, or in not the hillside, in the cliff face. And basically those fluids, if you take calcium, if you start with calcium carbonate and silica, those fluids, basically you replace all the CO2 from the carbonate and displace that and just leave you with calcium silicate, which is wollastonite. And it's been calculated apparently based off of the amount of wollastonite there, that there must have been a really huge volume of fluid that passed through there. I think it's something like 17 times the volume of the rock in fluid must have passed through. And the source of that fluid would have been mostly from these plutonic rocks intruding. As magma cools, water doesn't really go into very many crystalline phases, so any fluids tend to escape the pluton as it crystallizes, and then those would rise up carrying heat with them, and then metamorphose the overlying rocks. Just one other thing I'll point out is looks like there's some really crazy folds in those cliffs. They are folded. It turns out they're not quite as folded as strongly as it looks like they are. Part of the issue is that the beds are dipping, almost vertically here. And the cliff is also almost vertical, so it's what we call in geology a dip slope effect, whereby it's sort of like because the cliff face and the rock layers are almost parallel, just in undulations in the cliff surface cut in and out between different layers and make it look like they're strongly folded. And it's not that they're not folded, they actually are folded, but they're not folded quite as strongly as they look like they are. As for the lake itself, Convict Lake is a beautiful example of a glacial lake. So a glacier at some point came down this valley and carved out the valley, and then it left a big pile of moraines down there, or boulders and debris pushed by the glacier that then dammed the lake. Basically what we're standing on here is also a moraine deposit, so just a random jumble of boulders and rocks and gravel and all sorts of different sizes of stuff, all mixed together and shoved along by the glacier.